E5 vapor pressure lab. The vapor pressure lab deals with the vapor exerted by the molecules of a liquid in the gaseous state on the surface of the liquid. This pressure is due to the molecules in the liquid vaporizing to form the gaseous phase. The gaseous phase, the formation of the gaseous phase is dependent upon the vapor pressure, which depends upon the temperature. And therefore, it also measures the strength of the intermolecular forces that exist between the liquid molecules and how strong or weak they are. In this particular experiment, the vapor pressure will be determined for two different types of liquids. One is methanol and two is acetone. Now, before we go to the experimental part, what I would like to do is give you a tentative empirical equation for the relationship of vapor pressure and its temperature in absolute units with that of the enthalpy of various vaporization. The enthalpy of vaporization is defined as the heat energy required to vaporize 1 mole of a substance to its gaseous form under standard conditions. Now, the empirical equation is called as the Clausius Clayperyon equation. And mathematically, it is expressed as ln P2 over P1 is equal to minus delta HV over R 1 over T1 minus 1 over T2. Now, these relationship and the terms involved are P1 is the pressure at temperature T1 in absolute units. P2 is the pressure at temperature T2. Delta H is called as the enthalpy of vaporization, and R is the gas constant. Now, if you plot a graph of lnP versus ln versus 1 over T, then you will get a linear expression, the slope of which will be equal to minus delta H or V over R. The negative sign indicates that the slope is directed from left to right as per the expression. Now, I'm going to share my screen with you to show you how the experiment is conducted. So we go to the file, open a new lab, and look for the vapor pressure lab under V. So the vapor pressure lab, open it. Then all the information that I have given to you is over here in a slightly detailed form. And as we do it, I'm going to explain it to you. First, what happens is when you put a liquid, first, any container that is closed will have a vapor pressure equal to the atmospheric pressure at that temperature. Next, if you introduce a certain amount of liquid that quickly vaporizes at a particular temperature, then the total pressure inside the flask will be that due to the atmospheric pressure and the pressure exerted by the vapor. So in order to get the vapor pressure, then we will have to subtract the total pressure minus the air pressure. The air pressure at 20 degrees C and room temperature 20 degrees C, and the pressure of 1 atmosphere is 101.135 kPa. At higher or lower temperatures, it will either increase or cool down. In order to calculate the pressure, we find that we can use the Gay-Lussac's law, that is GAY-LUSSAC' law. P1 over T1 is equal to P2 over T2, and the volume of the container is kept constant and the quantity of gas is kept constant, so that we can get the adjusted pressure as equal to P1 over T1 times T2. Now, if you plot a graph, as I stated, you will get a linear equation, which is denoted by the expression ln P1 over P2 is equal to delta H vapor over R times 1 over T2 minus 1 over T1, where they have their usual signs and the descriptions. P1, P2 pressure, vapor pressure of the gas, T1, T2 the temperature at that. The gas constant R is 8.314 joules per mole Kelvin, and delta H is the heat of vaporization. So once we calculate it, then we'll record it at different vapor pressures at different temperatures and record it under the observation. Now, to go do this particular experiment, I'm not going to do the whole thing, but I'm just going to show you a short one, and then you can repeat the same experiment with all the instructions that follows. So first, I have to obtain an Erlenmeyer flask, go to the equipment, get an Erlenmeyer flask, and that's 100 ml Erlenmeyer flask. Keep it there. Attach the vapor pressure assembly, and you can see that it has the atmospheric clearly indicated as 101.135 kPa. Next, after that, you click on the vapor, and then you get here and add methanol, and it says you add 3 ml of the methanol. So we are going to go and add 3 ml of the methanol and say, okay. So now you have the methanol, 3 ml, 3 ml. Then next we go and prepare a water bath. A water bath. For the water bath, we have to take a 600 ml beaker, add 500 ml of water, use the dialog box, add 500 ml of water. So 500 ml of water, and say, okay, then insert a thermometer inside it, the water bath, and now record the pressure in the flask. So after you put the thermometer, you combine both the flask and the beaker together by highlighting the two and say combine, and there it goes in. Now combine this, record the pressure of the air inside after waiting for 3 minutes. Then once you do that, then what you do is click and say, you get a drop-down menu, say release the dropper, and then it will have released, and then again wait for 3 minutes to stabilize. And then when the pressure does not change, record the pressure, because you have the temperature initial and with the 3 ml methanol. Make sure you record it, and then Once it stabilizes, record the temperature and then enter it under the observation table as shown over here for each set of reading. Calculate the corrected volume, adjusted pressure due to the vapor, and get the vapor pressure in the flask. And once you do that, you can use the plot, go through all the sets, and after that, you get a new flask, add, set it up exactly like this, add the assembly, the gauge assembly that is there, then into the dropper you add the acetone and repeat the experiment and continue, repeat the experiment. Once you finish everything, remember to take the picture of all the samples that you have run, then copy and paste it into your Word document. After that, using the Excel sheet plot, you're going to plot the corrected pressure, vapor pressure, the vapor pressure against 1/T, and get the linear equation as well as the regression factor by using a plot of LNP on the y-axis and 1/T for the x-axis, and calculate the slope will give you delta H vapor over R. Once that is there, look at the direction of the slope and put the appropriate sign and complete the graph. And use the results from the graph to, and as well as any two pressures, what you have calculated are the two different temperatures. Calculate delta H vapor by calculation and from gas. Compare the two results. Use that for your discussion and then write down your conclusion. Complete the homework, and with that, this particular lab is over.